My name is Muhammad Izan bin Abdul Samad, and now I will be presenting the solution for problem B for our control system assignment. As you can see, first we find the root locus of the system. So for this case, we find the root locus is first find the zeros and poles from the equation as shown here. Then we find the limits for k, which is k must be greater than a certain value, -8/5, and k must be less than 7.053. Then from this value, we substitute into k based on this equation here, and then we can find the point in which the root locus crosses the j omega axis or imaginary axis. Then from there, we find the point of asymptote and the asymptote angles, and at the same time, we also find the breakaway points for the root locus. Then from there, we find the values of poles based on the graph. Then from there, we find the settling time, peak time, rise time, and of course the percentage overshoot. And based on the value of k based on the poles, we find the steady state error as shown here. Here's the root locus plotted, and based on simulation, which is after pasting this code here, this is the result that we get. And from here, we can find the value of k and the roots here based on the value of the damping ratio. Then from here, we can find the peak time, settling time, rise time, percentage overshoot, and of course, the steady state error. As you can see, it has the same steady state error as the calculation, and it also has a similar percentage overshoot value, but at the same time, the system is stable.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akif Shazwan bin Muhammad Amin. My matrix numbers is B0821100032. So for today, I want to explain about the question B, question C, and question D. So at the question B, next to improve the system performance. So we want to suggest we use the PID controller. So for the calculation, first of all, we use the PD controller, which is K2 multiplied by S plus K1 over K2. So we get the minimum pole is -0.5 plus minus J 1.10. So we get equal 1.530. So to reduce TS by the factor of 2. So TS new we get 3.92S. So after the all calculation, we get the new dominant poles is -1.02 plus minus J 2.20. So this is, you can see the imaginary and all. So after we get the all and we get the PI. So the PI we get S plus 0.01 divided by S. So for the C, to prove answer with the MATLAB or Simulink. So this is we get at the PD controller. At the PD controller, we have peak time at the transil, and we can see the steady state. So after we put the PID controller, so we can see we don't have peak time at the transil, and we can see the steady state error, so the smooth steady state error. So this is we improve, so we don't have peak time, you can see, and the steady state, you can see we improve. So the last question at the D, so implement the design controller. So we get 5k multiplied by S plus 0.26 multiply S plus 0.01 and divide by S plus 2, the power of 2, multiply by S plus 1 and multiply plus S. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hadi Aziz bin Amir. My matrix number is B0821100242. So today I want to explain E. We need to draw the board plot for system for gain K1, and we need to put K1 into our transfer function, and lastly we get negative 4.082 and identify board plot, can get gain margin and phase margin, and damping ratio from given 0.405. We use phase margin, this formula, and we get 43.58, and need to determine of value of K. Then we use this formula 1 over anti-log, and we get 1.8. Next, we need to define our MATLAB from bot plot. This is value of Kp of this loop for magnitude, and based on our this, we need to improve the design or using a bot plot. We need to define type 0, lag capacitor, steady state error, and we need to improve our transfer function, find value of Kp, and we need to know the Kp new. This is step is important for final also, so we need to know this step lah. And we got transfer function. We use the 20 log to find dB and put overshoot here, and use find damping ratio, and lastly find phase margin, and we got the magnitude. This is our design lag capacitor. This is MATLAB before our improve. This is after we improve, we got better result from value of Kp. Gain margin 9.22, better than gain margin before 15.6. And at frequency after this 1.65 is better than 1.69. So for phase, it's better value of Kp than before we implement this. This is our new transfer function. Alright, that's all from our group. Thank you.